The type of problem I want to work through now is called a limiting reagent problem. And this is a special kind of chemical stoichiometry problem. So I put some information on the board just so that way I can jump into the problem without having to take a lot of time on calculating molar masses or balancing chemical equations. If I have 3 moles of hydrogen plus 2 moles of nitrogen, that will yield 2 moles of ammonia, NH3. And this problem would be easy if I had exactly 2 moles of hydrogen, 2 moles of nitrogen to solve. However, the particular problem that I want to work through is, let's say we have 100 grams of hydrogen, and we react that with 100 grams of our N2. And the question is, how many grams of ammonia is that going to produce? The answer is not 200. And the reason why is, well, we have a different molar ratio between hydrogen and nitrogen, and more importantly, the molar masses of hydrogen and nitrogen are very different. So I can't just add the masses, it's grams, I can't add the masses together. I have to convert grams to moles and then use my chemical stoichiometry, my balanced chemical equation. But we'll see in the thought process of how we solve this, we actually have to do 2 calculations. So what I'm going to do now is I'm going to pretend that the nitrogen doesn't exist. That 100 grams, I'm going to ignore that data. And I'm going to calculate what's the maximum amount of ammonia, NH3, that I can produce from 100 grams of hydrogen. The one thing I'm assuming in this chemical reaction is that this is 100% yield. And I'll just put that on here. If it was 75% yield or 37.4% yield, I would have to take that into account. But for this particular problem, I'll make life easy. It's 100% yield. So, 100 grams of hydrogen, diatomic hydrogen, H2. And what we want to know, how many grams of ammonia can I produce with that, assuming I have an excess of nitrogen? And we'll address that a little bit later on. So now this is just a normal stoichiometry problem. I have 100 grams of hydrogen. I'm trying to get to ammonia, so I have to use the balanced chemical equation. Grams of hydrogen needs to be converted to moles of hydrogen. That's why I've got this value here. So 2.016 grams of hydrogen is 1 mole of hydrogen. Grams cancel. Now I'm in the unit of hydrogen mole. We're still trying to get to ammonia, grams of ammonia, but we have this relationship, 3 moles of hydrogen to 2 moles of ammonia. So, in my balance, or my factor label table, 3 moles of hydrogen is equivalent to 2 moles of NH3. I say equivalent because in this relationship, it's a 3-to-2 ratio. They're not identical, but we can equate them in this relationship. So now, moles of hydrogen cancel. Now we have moles of ammonia. We want grams of ammonia, not moles. So we do one more step, and I took the time of just calculating out the molar mass of ammonia. So the last step is 1 mole of NH3, not ammonia, is equal to 17.03 grams of ammonia. Moles of ammonia cancel. We have grams of ammonia, That's what we want. So now I pick up my calculator. 100 times 2 times 17.3 divided by 2.016 divided by 3. And I get 563.2. I put enough information on here so that I could have 4 significant figures. And that's fine. Is that my answer? I don't know yet. And the reason I say I don't know yet is because 563.2 grams is if I convert 100 grams of hydrogen to ammonia. But this is a limiting reagent problem. We also have to deal with the 100 grams of nitrogen. In a limiting reagent problem, we're going to run out of one of our chemicals, whichever, or one of our reactants, I should say. Whichever reactant we run out of, that limits the products that we make. So, that could be our answer. What we need to do now is the exact same problem, but using the 100 grams of nitrogen and ignoring the hydrogen. So, we set it up exactly the same way. 100 grams of N2, diatomic nitrogen, is going to be equal to some amount of grams of ammonia. Conceptually, the most difficult thing for solving a limiting reagent problem, we're going to do at least 2 equations. If there were 3 reactants, we'd have to do 3. We do 2 equations. One of the answers is correct. The other one is wrong. This is actually the best way to do it, in my opinion. There are other ways, but I'm not going to discuss that because those also require multiple calculations. So I'm going to just go ahead and finish this. 100 grams of nitrogen, grams of ammonia. So we have to convert to moles to use our balanced chemical equation. So 28 grams, 28.01 grams of N2 is 1 mole of N2. Grams cancel. Moles of N2, grams of ammonia. So we're getting closer. So now we go moles of N2 to moles of ammonia, and that's a 2-to-2 ratio. All right? So 2 moles of N2 to 2 moles of ammonia. Now, some of you might be saying, well, wait a minute, 2 divided by 2 is 1, so why am I even bothering to put that in? Can't I just skip to the next step? This is where you have to be careful, why you want to be patient with dimensional analysis. Mathematically, 2 divided by 2 is 1, but what we've really done is we've switched the units. Moles of nitrogen cancel. Now I'm in moles of ammonia. If you take a shortcut, you might end up putting the moles of ammonia on the bottom, and that will invert everything as we move forward. Don't take shortcuts. Always write everything out explicitly, even though in your mind you might say, again, 2 divided by 2 is 1, so how's that affecting the equation? The units are, all right? It's not just about the numbers, it's about the unit of measure. Moles of nitrogen have canceled. Now we have moles of ammonia, and look, we solve it exactly the same way as we did to finish the previous problem. 1 mole of NH3 is 17.03 grams of ammonia. And that should make sense that we finish this problem identically to the other one because we're solving for the same thing. So now I pick up my calculator, 100 grams of N2. And we get, or I get, 60.80. I'm rounding to the right number of significant figures. So which one's right? Well, 563 versus 60. It's always the smallest number. What this physically is telling me, if I react 100 grams of hydrogen with 100 grams of nitrogen, I run out of the N2 first. So this is our limiting reagent, N2, and 60.80 grams of ammonia, that is the maximum amount of ammonia that I can produce. In this particular problem, all I was asking you was about the NH3 that can be produced. But to find it, you inherently are going to figure out which one is the limiting reagent. The other question I could ask you about this particular problem is, well, how much hydrogen is left over? Because what's going to happen in this reaction is we're going to consume all of the nitrogen. We're going to make our 60.80 grams of ammonia, and then there will be some finite amount of hydrogen left over. But that's the subject for another problem.